So then, my friends, welcome to your first step into the world of TypeScript. In this masterclass course, I'm going to teach you all about TypeScript from the ground up, including how to work with a ton of different data constructs like classes, interfaces, type aliases, generics, and all that jazz. And by the end of it, you should be comfortable making your own applications using TypeScript. We're also going to be using what we learned to create a couple of real-world mini projects along the way, including a CSV file writer and a small web application. We'll also be looking at how we can work with TypeScript in a Next.js application as well, so there's absolutely tons to learn. To begin with, in this first lesson, I just want to broadly focus on what TypeScript is and what the benefits of using it are, because I think knowing this from the start gives you a little bit more motivation to learn and hopefully remind you along the way why we're doing certain things. So then, in simple terms, TypeScript is a programming language built on top of JavaScript to give it extra features, primarily the ability to add types to values. So whereas in JavaScript, we don't need to specify what type of data gets stored in variables, for example, a string or a number or a boolean, etc., and we're free to change that type of data as well at any point. In TypeScript, once we decide what type of data should be in a variable, that type can't change at a later point in time. So if we say a variable is a string, it can never be a number or any other type in the future. It must always be a string. The way we describe this is that JavaScript is loosely typed and TypeScript is strongly typed. Then you might be thinking, well, if TypeScript is making me choose specific types for variables and then not letting me change that type, isn't that going to make my life harder as a developer? Where's the benefit of forcing me to choose types and stick with them? Well, you might not notice them right away, but there are several reasons using a strongly typed language like TypeScript is beneficial. First of all, if TypeScript knows the types of data that you're using ahead of time, it's going to give us good error feedback as we code if we make a mistake. For example, I have a function declared which specifies the type of argument it takes in. It must be a string. So when I come to use that function later on, I'll get an error if I try to pass in the wrong type of data as an argument. If I hover over the error, I can see that we need to pass in a string, so I can fix the error way ahead of runtime. And that means there should be less bugs in the code when I do come to run it eventually. We don't get that kind of type checking with JavaScript, meaning probably more runtime errors, which are harder to debug. Secondly, when we use TypeScript, we get better auto-completion and code hints because VS Code knows the type of every bit of data that we use. So it knows all the properties and methods attached to every bit of data, and it provides better feedback when we try to use a method or property that isn't available. For example, TypeScript knows the data type returned from this function is a string, and so it gives me auto-completion for all the string methods and properties I can use. If I try to use an array method not available to strings, then it's going to cause an error, which again I can fix ahead of runtime. Again, we don't get much of this kind of functionality with regular JavaScript because the types are not explicitly defined, so it doesn't know what type of data gets returned from a function all the time. Also, TypeScript allows us to make custom types in addition to the standard types, like strings, numbers, and booleans. They're all built into the language, and we can make those custom types by using interfaces, classes, and type aliases. Now, don't worry too much about the specifics of that for now. We'll talk about all of them later on in detail, but as a quick example, I could make a data type which represented maybe a menu item, and I'd say that all menu items must be an object with a title property, which is a string, and a cost property, which is a number. Then I could use that as the type of an argument within a function, so that when I come to use the function, TypeScript is going to make sure I pass in an object with those two properties, which represents a menu item. So let's give this a quick whirl. We know this print menu item function must take in an argument which is of type menu item right here, which is an object basically with those two properties, title and cost. So I've got a few examples down here that I'm just going to uncomment one at a time. So the first example is where we try to invoke the function without passing in an argument, and we get an error. So if we hover over that, we can see it expected one argument but got 0. An argument for item was not provided, so it tells us we need to pass in the item. And also we see this function right here showing us what type of data that item must be. All right, so that's some helpful feedback. Now, if we go down here to the error example 2, I'm going to uncomment this. This time we invoke the function, we pass in an object, which we should do. We have a title, which is a string, and then we have another parameter, or another property rather, called cost, which we have over there, but this time that's a string. So because this must be a number, we get an error. Or right here, and if we hover over that, it says type string is not assignable to type number. The expected type comes from a property cost, which is declared here on menu item to be a number. So it tells us this must be a number, all right? Which is pretty good again. So down here, if we comment this one, this time we pass in an object, which we should do with a cost, which is a number this time. This time, another property called name, which we don't have. It's a title property. So if we hover over this, it says right here, the argument of type, this right here, this object that we made is not assignable to parameter of type menu item. And it says that name does not exist on the type menu item. So it's telling us this is not a valid property. So again, some pretty good error feedback. This is the correct example where we pass in an object with exactly the correct properties right here, title and cost, and they're the correct types as well. So this works. Another benefit of using TypeScript is that your code essentially becomes self-documenting because we're explicitly defining all the types of data that get passed around within it. And it's easy to look up these different types, functions, and other definitions when you need to. For example, if someone else had written an application which defines this function and the menu item type, I can go to the definition of the function in VS Code by clicking on it and then hitting F12. That takes me to where the function was defined, so I can see what it does. I might not be sure what a menu item is, so I can click it, then press F12 again, and it takes me to the definition of that interface. So now I can see that it needs these two properties. So when we're using TypeScript and we're defining these different functions, arguments, and custom types, we're essentially documenting the code as well. And that makes it much easier for us or other developers to navigate the code at a later point in time. So although at first it might seem like using TypeScript is a bunch of extra effort for a little reward, the rewards can actually be really significant, especially as your applications get more complex. You just need to push through that initial learning barrier to reach that point. So a nice way to think about TypeScript is that it's basically just the same as JavaScript, but with some extra annotations sprinkled on top. That's all it essentially is. And I found that thinking about it this way makes the learning process much less daunting and confusing. So anytime you're feeling a little bit lost, just remember that TypeScript is just JavaScript with those extra little annotations on top to define value types.